Chapter 11, Inheritance and Polymorphism, back at it, and now the focus is on that second word, polymorphism. What really is this? Big concept for object-oriented programming. What does it mean? The short answer is the idea that any time we have an object of a supertype, we can send to that object a reference of the subtype. The idea that an object of a subtype can be used or can be sent to anywhere where you have an object of a supertype. So for clarity, if I just come over here, this is my default, my garbage program. I'm going to make a new class. I'm going to call this student. I'm not going to make the whole class. I'm going to do it really quick and dirty one. Zoom in, and we have here, I'm just going to make a string first name, string last name. And I'm not even going to make the getters and setters. There's no need for the purpose of this example. But now in my garbage, I can make a new student, right? Super simple. I can make student s equals new student. Easy. I can also make object o equals new object, right? We've seen creating an object of the most vanilla type of class, the object class. Well, check this out. I can say object, let's call it O2, equals new student. That, in a nutshell, is polymorphism. The idea that I can create a new student object, take its address, that object is on the heap, and I can save the address of that student into a reference variable of the supertype. In a nutshell, bird's eye view, the trailer of the movie, this is polymorphism. The idea that the object of a subtype can be used wherever its supertype value is required. So I say, imagine we make a method that takes one parameter. This parameter is a reference variable to an object of the most generic type, the actual object of type object. We can send to that parameter, to that formal placeholder, that formal parameter, we can send to it a reference variable of any type, of a type object or of any subclass of object. This is the overall idea of polymorphism. Here's an example we're going to go through in complete detail, and let's pay attention to how many actual classes we have here. We have the three blueprint classes, as I call them. We have the graduate student class, we have the student class, and then we have here the person class. Notice for the person class, I typed extends object. Obviously, I did not need to type that explicitly because, as we mentioned previously, if a given class does not explicitly extend any other class, it automatically extends object. So there's no need to type it, but just there's also no harm. I wanted us to feel that inheritance that's going on here. So person is extending from object, student extends from person, and then graduate student extends from student. And each time, of course, as we know, when we're extending, we are going to inherit all accessible data members as well as all accessible methods. So these are the three blueprint classes. In each of those classes, or certainly within the student class as well as the person class, notice that they have their own overridden toString method. So, of course, person, since it is extending the object class, the person is inheriting that trash public toString method that comes from object, right? But immediately what did person do? It said, yeah, thank you so much, object, appreciate you, but yeah, that method's trash. We're going to get rid of that one, and instead, we're going to make our own toString method here inside the person class. That's what the person class does. The student class does that same thing. When the student class extends from person, the student's like, yeah, thank you so much, person class. Appreciate that toString method that you allowed me to inherit, but I don't really like it. I'm going to make my own toString method. Now, the graduate student, which extends student, the graduate student inherits this toString method from the student class, and it chooses not to override it. So there is a toString method right here, right inside graduate student. And that toString method, what does it do? It simply returns student, because the toString method for graduate student is the one that comes from student because it was in fact inherited. So important here is that person and student, they have their own toString method, while the graduate student does not have its own. In fact, instead, it inherits the one from person. Polymorphism. This is the demo class at the top. We have this method M. Pay attention to method M and what's going on here. This method M, it's a void method. It doesn't return anything. It's a static method. It simply belongs to this class. And what does method M receive as a parameter? It receives this variable x. What is the data type of x? It is the most vanilla, generic data type possible. X is a reference variable to an object of type object, which means, as we just said on the previous slide, what can we send over here? We can send to this formal parameter, to this placeholder, we can send any subclass of object. We can send over person, we can send over student, we can send over graduate student. Any subclass can be sent. This is the idea of polymorphism. So when we send over a reference variable, maybe that reference variable is of type object. Maybe it is of type person or student or graduate student or anything else. What are we going to do with that reference variable inside method M? We are merely going to have a single print statement that prints the toString method of that particular object. That's all that happens. And then finally, when we work ourselves the way up, we see we have this main method. The main method has only 4 lines of code. Inside that main method, we have 4 lines of code. Each one of them merely invokes this method M. We're calling method M, and we're sending to method M. On the first line of code, we're sending a reference to a graduate student object. On the second line of code, we're sending a reference to a student object. In the third line, we're sending a reference to a person object. And finally, on the fourth line, we're sending a reference to an object. Now, for clarity, let me come over here back into my garbage program, and let us pretend that we have made, let me make this method M very quickly. Public static void M object O. When I call it O, I'll call it object X to be consistent. And what are we doing here? We are merely printing x dot toString. Okay. So what can I send over to this particular method M? I could send an object O, right? Or I can send any other. So let me make object O equals new object. I could then print, I could call method M, I could send over S. I could call method M and I could send over the object itself. I could send over a reference to the object, or I can send over a reference to this student. But I want you to see, so first of all, that works. And if I print this, it's going to be trash because I haven't overridden anything, right? I haven't saved anything in there. If I wanted to come back to the student, just for kicks, right-click, insert code, constructor, insert, select all, generate, right-click, insert code, getters and setters, select all, encapsulate, generate, and let me actually make this student with a first name and a last name, with Kaya Smith. All right, so now and let's make a toString. Let's right here, save this, right-click, insert code. For the student, I'm going to insert a toString, and generate. That is good enough. And so now when I come over here, when I run this code now, notice instead of printing that trash that it had before, right? If I come over and I get rid of this toString, I'm going to get rid of the toString inside the student class, and I come back and I run this code, what does it print? When we send over S, it prints this. It's basically printing the it's printing the inherited toString from the object class, which is trash. So here I have the overridden toString that was just made by NetBeans. So now when I run the code, I get this. But this is not what's important. We've covered that already. What's important here is the polymorphism, the understanding, the idea that I can send to this parameter. This parameter is called object. The data type is of the most generic object. It's object, which means I can send to this parameter a reference of type object, which I'm doing here, right? So I can get rid of this Kaya Smith. I can get rid of this. So here I'm making a new object. I'm saving it into this variable O, and I'm sending over a reference of that variable O over here to M, and I run it, and I get this. No harm, no foul. But what if I then want to, after doing that, say, you know what, I want to make a new student, and I'd like to send over that student's reference. So I make a new student, I save the address of that new student into this variable S, and now I call a method M, and I send over the address of that new student on the heap. Well, this is what is inside S. It's an address to a student object. But we can, in fact, send that student object over here to a supertype. So this is the subtype or the subclass. This would be the superclass or the supertype. Polymorphism is you absolutely can send a subtype to where a supertype is expected. Is it a weird analogy to do the following? If I had public, static, void, sum, method, double, X, and the idea that, as we've seen before, I can send over to some method, I can send over, of course, a double, right? That works. But I can also send over an integer. Why is that allowed? Because this is smaller than the double, right? We can send over a 2 into the double. Not that we have the same exact analogy here that a student is smaller than an object, but you get the idea. It's just drawing from that analogy that we can send an int to where a double is expected. Here we can send a student to where an object is expected because a student is a subclass, it's a subtype, and this is the idea of polymorphism, which is what's being shown and depicted here on this slide. But I want to also just, this is not necessarily related, but in case there's any hang up when someone's looking and saying, hey, how are we calling this method M and sending over a new student directly inside the parentheses? What's going on here in that particular sample on that slide is we're doing this. We're calling method M, and right here inside the pair of parentheses, right here's a pair of parentheses, we're sending over a new student. What's really happening inside this parentheses right here, we're saying, yo, Java, make me a new student object. Make it on the heap with these two parameters. Call the constructor with Kaya and Smith. Make me that object. Java does that for you. It returns to you an address of that object, and then you send that address over here. That's what's going on. And so we can do it in one line, as you've seen us do right here. You could do that. Meaning you could put the call to the constructor new student right here as a parameter to this method M. You could. In fact, that's what's done on this slide. Why is that? Why is it better, however, to do this? If we were to instead to say student S equals new student and then call M with sending over S. I would argue this is better even though this is allowed. Why would that be better? Pause the video, spend 15, 20 seconds, and come back and see why this second one would be better than the first. And the answer is simply that if we have no reason to ever need this new student, the reference to this new student object within our main again, there's nothing wrong with the first one. But what if later down here, what if I wanted to be able to update that student's first name or to do something else or to print that student? If we had only done this, I don't have access to that student anymore, right? Whereas had I done it this way, later I could then print, the student. I could maybe, if I needed to set the first name, I could update the student. So it's better to, of course, do it with these two lines of code. as opposed to calling method M and directly inside the call to method M, sending over a reference to a new student object that is being created on the fly. Nothing wrong, but certainly better than this. But I want you to understand those are both effectively doing the same thing. So now let's break down what actually happens when I, on this first line of code in main, when I call method M and I send over a new graduate student. So a new graduate student object is being created. I'm going to send over that graduate student object. It's going to come right here. It's going to get saved into a reference variable of type object, but it's still a graduate student. And I need to print its toString. So I want you to answer what is going to get printed right now when it prints the toString of X, knowing that what really is X right here? X is going to be a new graduate student that was just sent over, and it was saved inside X because we're calling this method M. So what's going to get printed? Pause the video, think about that, try to answer the question. Here's the answer. Well, what gets printed is we are invoking the toString of X. What is X? X is, we see here, an object, but in fact what was sent over was a graduate student. So we're going to invoke the toString of graduate student. And when you look here, you don't see a toString. But we know that graduate student extended student, which means it inherited this accessible, this public toString method, which simply returns student. So the toString of graduate student is really this method right here, which returns student. The word student gets returned right here, and we print the word student. Let me ask you on the next one. When we call method M and we send over a new student, what gets happened? Or what happens? We're going to send over, we're going to create that new student object. We send over an address to that object. That address gets saved in X, and we print X.toString. Well, X is what? It's an address of this new student. So we're going to come over to student. It does in fact have a toString, and we return student. The word student gets printed. Here we come to this third method M. We call method M, we create a new person object on the fly, and we send an address of that new person object over to method M, and the address of that object of the new person gets saved into X. And what ultimately gets printed? X.toString. It will invoke the toString of the person class, which will print the word person, or it will return the word person, which gets printed right here. And then finally, when I call method M and I send to method M a reference to a new object of type object, which was created on the fly, when I call that method M, I send over a reference to this object of type object. That address gets saved into the variable X. We then call X.toString. Which toString is getting invoked? The toString of the object class. What we just described here is really the next topic written at the top, dynamic binding. So what happens when we invoke method M? A reference to some object is sent over to method M. What kind of object? So we're sending over a reference to some object that gets saved into the variable X. But the reference that was sent over, it could have been a reference of type student, it could have been a reference of type graduate student, of type person, or even just a reference to an object of type object. Inside this method, there's a single print statement, which invokes the toString method of the given object that was sent over. So remembering that X may be an instance of graduate student, or an instance of student, or of person, or of object, and remembering that each one of those classes may perhaps have their own unique overridden toString, the question simply becomes, which implementation of toString is ultimately used when I come here and I send over a new student? And then the new student object comes right here, and then we call X.toString. What's going to get printed? Which toString is going to get invoked? Is it this toString of the student class that gets invoked since I sent over a student? Is it this toString of the person class that gets invoked? Is it the toString of the object, that trash toString method that gets invoked? Which one gets invoked and how is that decided? This is known as dynamic binding. And which toString ultimately gets invoked is determined dynamically by the Java virtual machine at runtime, and this is called dynamic binding. So I think we fully understood this example and which one's ultimately getting printed. Now we get to the official definition. Suppose an object O is an instance of all of these classes. So here, if we have a graduate student, well, a graduate student is an instance of graduate student, but a graduate student is also an instance of every superclass above it. So a graduate student is an instance of graduate student. It's also an instance of student. It's also an instance of person. And a graduate student is also an instance of object. So suppose an object is an instance of all of these classes, where C1 is a subclass of C2, C2 is a subclass of C3, C3 all the way up to Cn, where Cn is the most generic, the most vanilla, and C1 is the most specific. And in Java, of course, we know that Cn, that most generic class, is the object class. If this object O invokes some other method P, the Java virtual machine will look for an implementation of that method P within C1, C2, C3, all the way up to Cn in that order until it's found. Meaning the Java virtual machine will first look in the more specific classes and look for an implementation of toString. If it doesn't find it, it will look for the implementation of toString in the superclass. If it doesn't find it, it will look for an implementation of toString in that superclass. It'll keep going all the way up the chain looking for an implementation. And once it finds one, that is the implementation that is invoked. This is the idea of dynamic binding. So using our example, when a student object invokes the toString, the Java virtual machine will first look for the implementation inside student, then inside person, and then inside object if it was not found elsewhere. Now, of course, on this example here, when we invoke method M with new person, of course, we see that there is in fact already a toString available, and we will therefore return person. Same thing when we invoke it with student, there's already a toString available for student, and we return student. This is the idea of dynamic binding. Now, this is a little bit related to method matching and method overloading. Matching a method signature is different than binding a method to binding a method implementation. So matching methods to a given signature with method overloading, that is done at compile time. The compiler will find a matching method according to parameter type, the number of parameters, and the order of these parameters, and that happens at compile time. So when you call a method, as you've seen when coding, if your program cannot find a suitable matching signature for that method call, it'll give you a compile error before you even can run your program. Whereas binding a method, what we just described with dynamic binding, this happens at runtime because a method may in fact be implemented in many different subclasses. That toString method was implemented in the object class, it was implemented in the person class, it was implemented in the student class, and even the graduate student inherited that toString method from the student class. So we have many implementations of that toString method. The question is, which one do we use? That is ultimately determined by the Java virtual machine at runtime, and that is called dynamic binding. So all of this is a lot of words, right? We gave an example, but still a lot of words. What's the value of all of this? What is really the value proposition? Polymorphism allows methods to be used generically for a wide range of arguments, which leads us to a very, very important programming paradigm, the idea of generic programming. If a method's parameter type is a superclass, right? So here, the parameter type of method M is a superclass. It's the superest of superclasses here. It's the object, right? That's the data type here. The consequence, and this is a good consequence, is you can pass to this method an object of this method, the object of type object, or any of its subclasses. We can pass to here a person, a student, an undergraduate student, if we had such a class, a graduate student. So we can pass to method M an object of type object or an object of any of its subclasses, which allows for this method M now to be very generic. I didn't need to make 4 different method M's, one for person, one for graduate student, one for undergraduate student, one for whatever. I only made one method M with a very vanilla parameter, and I can send any type of object to that parameter. This opens the door for generic programming, but then I say here, yeah, but still, I'm not seeing the value proposition. What, again, is the pitch here? So imagine we have this method header called update record. So this is a different program, right? We have some program that has person objects, so we have a person blueprint. Maybe in the person, we of course could have a student, maybe an employee, maybe under student, we have some subclasses, undergraduate student, graduate student, maybe under employee, we have subclasses, as staff member, faculty member. We can keep going on and on with the inheritance. But now we have this method called update record, which receives a person object, right? And the purpose of this update record is maybe, just like in normal time, you might sign into a website and it says, hey, before you continue, update your information. Is your address the same? Is your email? Is your phone number the same? Just an update before they allow you to continue on, right? So imagine some update record method is being called to update the information about your person, about you, right? The purpose of this method is, as I just described, to update the data members for a person, maybe very generically. We could send to this update record method a person object, or because of the idea of polymorphism, we could send to that method a more specific type of person, a subclass. We could send to it a student object, an employee object, an undergraduate student object, a graduate student object, a faculty member object, a staff member object, right? We can send it all kinds of objects due to this idea of polymorphism. We can send over a person object or any subclass object. Again, what's the value? Third time I've asked that question, here's the value. What if we did not have polymorphism? What if we did not have polymorphism and we wanted to make an update record method? What we would have to do is we would need to make an update record for student. It would be something like this. We would have to make all these different methods. It would be public, static, void, update, record, person, right? Update record person. And I would send over person P. And of course, I don't have these classes, so it's going to give errors, and that's okay. But I'm just going to put this here. I would also have to make another method, public, static, void, update record, student. Update record student, student S. Another method, I would have to make a public static void update record, and this would be employee, employee E. Right, you get the idea. I have to go make another one, public static void update record undergraduate student. And I'd have to send over the undergraduate student, US. And we'll do one more for kicks. Public static void update record graduate student. Graduate student, GS. So imagine we had made all these different blueprints, person, student, employee, undergraduate student, graduate student, maybe faculty, and even staff member. We would have had to have made, if we don't have polymorphism and we want to do an update record to be able to update the information of those objects, what if we just want to update the basic information? Their address, their maybe their first name, last name, maybe someone changes the name, their email, their phone. We would have to have an update record for each and every one of these individual objects. So if you were an employee, we'd have to call this update record. If you were a student object, we'd have to call this update record. If you were a graduate student, we'd have to call this method, update record graduate student. We'd have to call the specific update record method for that specific type of object that was being sent, which is crazy. But because of polymorphism, we can do this. We don't need all of those. We only need one update record method, and we're going to send over person or any subclass of person. So now instead of having these 5 or 6 or 7 or more update record methods, we only make one update record method. In this generic method, we can update all that information we need that was shared among the various subclasses. Maybe they all share first name, last name, address, email, phone. We can update that information. And even cooler, within this very generic update record person class, so we could have said here, maybe we sent over, we asked the user, do you want to update your first name? Yes or no. We scan their first name, we save it. But now we want to say, hey, if P, what is P? P is a reference to an person object. We could say, well, if P is an instance of a student, and I'm getting ahead here, but we'd say, hey, if P is really, truly a student, not just a person, but an actual student, maybe we would then update student information, student-specific information. Else if P is an instance of employee, for example, which it will now give an error because it doesn't know what employee is, we could update employee-specific information. But then first up here, we would update the generic person information, right? The information stored as data members in the person class that is shared among all the subclasses. So this is the value of polymorphism, being able to send to this method not just a reference of type person, but a reference of any subclass of person. It now allows for generic programming. And again, what is the value here? So instead of just one update, instead of having 5, 6, 7 or more update record methods to update records of specific type of objects, a student object, an employee object, or what have you, we have one method where we send over any of those subtypes, and we can now do that via polymorphism, allowing for and opening the door for generic programming. Huge deal. And you know what, looking at the time here, 32 minutes, we will do casting on the next video. I want to jump ahead to coding. So what did we do previously? We had these 3 classes, the geometric object class, the circle class, the rectangle class, which both extended that geometric object class. We made the overridden 2 strings. We want to now update that by just adding a third subclass, triangle, which will have, of course, 3 sides of a triangle, side 1, side 2, side 3, all integers. We want to make that new class, that new blueprint, make all getters and setters, make the get area, get perimeter method, make its 2-string method. That should be identical to what we had with the circle and the rectangle. So like we already had a rectangle and circle that extended geometric object, we just want to make one more of these just for practice, right? To keep kicking the ball, practice making of the triangle blueprint, a triangle class. But when we're done with that, we want to update main to now make a generic print method that uses polymorphism. So first, let's come over here. Let's make this right-click, new Java class, and let's make this triangle. Make a new class called triangle. Let's zoom way in. Let us right-click. Nope, not right-click yet. Let's do int. Come on. Int side 1, int side 2, int side 3. Let me right-click and insert some constructors. Insert code, constructor, done. Right-click, insert code, constructor, all 3 of them. And then right-click, insert code, and getters and setters. Let us select all encapsulate fields. And then finally, right-click, insert code, and let's insert a 2-string. Let's hit generate, and of course we will put our own 2-string. We also need to make, let's go ahead and make the toString. The toString should look just like circle or look just like rectangle. Right, here's those two strings we had made previously. So I'm going to copy this toString. I'm going to bring it over to triangle, erase what's here, and paste this in its place. Of course, it's not called a rectangle, it's called a triangle. We're going to call the super.toString, which will then call the geometric object toString, and it'll print the color of the triangle. It'll print whether or not that triangle was filled. And then we need to print the details of the triangle. Do we want side 1, side 2, side 3? We could. Here's side 1. Let's do that. Side 1, side 1. Let's do that for each one of these sides. Side 1, side 2 and 3, side 2 and side 3. Change that here. Side 2 and side 3. Of course, we can delete the height. And now we have the area. So we need to call our get area, get perimeter methods, which means we need to make an area and a perimeter of a triangle. So public int or public double get perimeter, and this get perimeter, what is the perimeter of a triangle? Return side 1 plus side 2 plus side 3, and that will get returned. That is the perimeter. And then public double get area. What is the area of a triangle from 3 sides? If you go Google that, you will get a very funky looking equation that we likely saw at some class in high school, and guaranteed did a quick delete or reformat after seeing that reformat on our brains. It's a weird equation. We don't need to understand it perfectly, though, in order to use it. So through the power of pause, there we go. This is the equation for area. For get area, here's the method. Ultimately, we have this area equals math times square root times this stuff. Notice there's a p in here. What the heck is p? Well, p is basically perimeter divided by 2. I didn't have to make my own variable for that. I could have just, wherever you have p in this equation, I could have put perimeter divided by 2.0. That wouldn't have been very exciting. It would have made for a very long equation here on line 46. So instead, I made the variable p. I did this. We don't need to understand it in order to use it. So pause the video, get this get area method, type it up. It'll take you a minute and a half or so, and then come back. But now that we have this done, we have the triangle method, the triangle blueprint taken care of. I can come back over here to our geometric object class. This is done. I come back to my inheritance practice class, and now let's add a triangle t equals new triangle. And I forgot one thing I realized. I have not included something super important. Extends geometric object. And of course, when I extend geometric object, let me even erase this constructor, and I'm going to right click and reinsert it, constructor. And here I'm going to select all of these, and I'm going to select this one particular constructor here, and I hit generate. That's now a lot better. I'm sending over the 3 sides followed by the color and then filled, which then will invoke the superclass constructor of geometric object, which we've covered. So here I'm going to make a constructor. I'm going to call the constructor with 3 parameters. How about 2? Let's do a 2, 2, 2. A very simple triangle with the color purple, and you bet it is filled. Done. And so now I want to merely print out t. Let's run this code, make sure that we have an error. Let's make sure we have no issues. What do I want to say? And of course I have an error. It's going to be something simple. I printed out t and inheritance practice t. I love errors. Where is it? I really love debugging. To me it's fun. I know it's super crazy. Let's see. It is saying here on line 15, system.out.println t. And what does the error actually say? What error occurred? What was the error? Right here. Illegal format conversion. F does not equal integer, but I figured it would be going on. So it is going over. So here we are. We are in triangle on line 61. Of course, because it is a decimal. That was big brain. I love big brain moments. That was fantastic. The data members were in fact integers. Okay, that was 60 seconds, but you get to watch me debug. Let's come run this again, and here we go. Triangle is of course a geometric object. Rectangle, a geometric object. Circle is a geometric object, and the first one up here was just a basic geometric object. All is well. Here is our triangle. We have the three sides, we have the area, we have the perimeter. All right, so what I want to do is the last thing is I said, let's make a vanilla method. Public static void print object X. So we want to make, instead of calling the print statement, this is a silly usage of polymorphism, what I'm about to demonstrate, but we just want to show this. Now that I've made each of these four objects of type geometric object, then circle, then rectangle, then triangle, I would like to, instead of printing here, just to demonstrate how polymorphism works, I would like to just type print GO, and then print C, and then here print R, and then finally print T. And of course, hear me clearly, this is not the most enlightening example of polymorphism, but when I call the print method, this is some print method, right? When I call this print method and I send over any one of these four reference variables, well, I'm sending those four reference variables to a very vanilla placeholder here, this formal parameter of data type X. And so now when I just say, hey, print X dot toString, I don't need to explicitly type the toString. I could just say print X, and as you know, Java will invoke the toString anyway. But when we invoke x.toString, does it print the toString method of the object class, that trash one? Or will it print the toString method specifically of triangle, or of rectangle, or of circle, or of Go? Well, when you run the code, you see it in fact invokes the appropriate toString method for whichever reference was ultimately sent there. This is the idea of polymorphism, that we're able to send over to this method any one of those particular objects. And now within this method, I can absolutely say, well, hey, if X is an instance of geometric object, I can do something particular. Else, if X is an instance of circle, do something else. Else, if X was an instance of rectangle, do something else. Else, if X was an instance of triangle, do something else. So now we can do specific updates, or we can print specific things based off of the data type of X. Was X just an object? Was X a geometric object, or a circle, or a rectangle? And we could do something specific here, if that makes sense, but that has to do with casting, which is where I ended the slide, and that is going to come next time. So go ahead and pause the video, type this up, because we will pick up on the next video right here with casting, with using this instance of. It has been fun. As always, reach out, leave a comment, ask questions. Take care, everyone.